Now let's discuss a few examples of function composition. And we'll start here. We'll start with f of x equals 3x plus 1 and g of x equals x minus 2 all divided by 3. So remember that function composition is a type of layering of functions. For f composed with g of x, what we're really thinking is we're taking the function f and we're using g of x as an input. So anywhere in f that I had an x, I now want to have a g of x. So I end up with 3 times g of x plus 1. But we know what g of x is. G of x just stands for this function here. So we end up with 3 times g of x, the actual equation for it, plus 1. Now notice here I'm multiplying something by 3 and also dividing it by 3. Those are inverse operations, so those are just going to cancel to make 1. So what we're left with is x minus 2 plus 1, or x minus 1 when I combine my like terms. So we have an equation now for f composed with g of x. Now because function composition is not commutative, if I switch the roles, if I take g and use f of x as an input, I have to recompute. I can't just say, oh, it's going to be this, because it's not commutative. I don't know that, and in most cases that won't be true. So now I want to take g and use f of x as an input. But again, I know what f of x is. It stands for 3x plus 1. So I end up with this equation. I can combine a couple like terms here. So now we have an equation for f composed with g of x, and also an equation for g composed with f of x. Notice they're not the same, and that's true for most compositions. So now that we have this nice argument notation for composition, I can write things like this. I can ask you, or we see sometimes, g of f, or g composed with f, of 1 instead of x. So I don't want an equation like this anymore. I want to get the output when I input 1. So because we already have this nice equation for g composed with f of x, all I have to do is substitute in 1. It's going to be my input. So I get 3 times 1 minus 1 divided by 3. So my answer there will be 2/3. So g composed with f of 1 is 2/3. Now what if we hadn't had this nice equation for g composed with f of x? I could always go through and find it, but we actually have another way we can do these types of problems where we don't have this equation. And let's try that with this second example here. We have f of x is 2x and g of x is this quadratic here. And what I want to find is I want to find g composed with f of negative 2. But we don't have an equation for g composed with f of x yet. We haven't figured that out. Now we could go through, find g composed with f of x, and just substitute in negative 2 as our input. We can also find f of negative 2 and go from there. Because what we really have here is we're taking g of x and we're using f of negative 2 as an input. Well, we know how to find f of negative 2. We just used negative 2 as our input. So it's going to be 2 times negative 2, or negative 4. So I know f of negative 2 now. It's negative 4. So really what I have here is g of negative 4. But g of negative 4 just means negative 4 is my input into g of x. So I get negative 4 squared minus 5 times negative 4 plus 1. That's g of negative 4. So I get 16, and I have minus 4 times minus 5, so I get plus 20 plus 1. So my answer is going to be 37. So g of f of negative 2 is 37. Now let's go through and do it the other way. Let's find g composed with f of x, and just double check that we're right, that both ways would really give us the same answer. So again, this is g composed with f of x, meaning f of x is our input, g is our function. So 2x is going to be my input into this equation. So we get 2x squared minus 5 times 2x plus 1. Well, 2x times 2x is going to give me 4x squared. Remember, it's not just 2 times x squared, it's 4 times x squared. Then I have minus 10x plus 1. Now let's just double check. If I substitute in negative 2 here, I get 4 times negative 2 squared, which will give me 4 times 4, or 16. Then minus 10 times negative 2, well, that's going to give me plus 20. I have plus 1. Still going to give me 37. So either way, if I find f of negative 2, substitute it in, and then find g of negative 4, I get 37. If I find g of f of x first, the formula for it, and then substitute in negative 2, then I also get 37. Both ways work. So let's look at a couple more examples. This next example is going to be a little bit similar to number 2, but not quite the same. For f of x, I'm going to take x plus 1. For g of x, I'll take this quadratic x squared minus x plus 5. So let's find f composed with g of x. So that means I'm going to take f and use g of x as my input. I'm going to layer my functions that way. So I'm going to take g of x and just add 1 to it. So g of x is x squared minus x plus 5. So I'll get x squared minus x plus 6. That would be my equation for f composed with g of x. Now let's find g composed with f of x. So I'm going to layer them the opposite way, right? I have g as my major function and f is going to be my input. So notice in this case I have 2 places where I need to put f of x in. I have f of x here and here. So I have f of x squared minus f of x plus 5. But we know f of x. It's just x plus 1. Notice I kept my f of x in parentheses. That will remind me if I have a number here or if I have a negative sign here, I need to distribute it across f of x. So that reminds me that it's not just going to be minus x plus 1. I have to distribute that negative. I'll get minus x minus 1. Also, I need to remember when I take x plus 1 and square it, I'm multiplying x plus 1 times x plus 1. So I actually need to multiply that out fully, or FOIL if you're comfortable with foiling. So I'm going to end up with a middle term. I have x squared for my first terms, then I have a plus 1x, and then another plus 1x, and then a plus 1. So plus 2x plus 1. Again, we said we're going to distribute that negative across, and then my plus 5 stays. So when I combine my like terms here, I end up with x squared plus 2x minus x gives me plus x, and then plus 1 minus 1 will give me plus 5. Now notice that these two are very similar, but they're not the same. And we are not surprised they're not the same. We just have to be careful that we're making sure that we're computing them both carefully and correctly. Let's take one last example. this one, f of x is going to be x plus 1 divided by x minus 3, and g of x is going to be 2x minus 4. So let's take f composed with g of x to start. So that means I'm layering so that f is my function, g of x is my input. And notice, just like we did in number 3, there are going to be two places where I need to put in g of x, one on top, one on the bottom. So I get g of x plus 1 over g of x minus 3. But g of x, as we keep saying, is just representing this equation, or this function. So we get 2x minus 4 plus 1 over 2x minus 4 minus 3. That tells me my equation is going to be 2x minus 3 all over 2x minus 7. So that would be my equation for f composed with g of x. Now let's find g composed with f of x. Well, in g, I only have one place I'm going to need to substitute f in when f is my input. So I have 2 times f of x minus 4. But f of x is just that function. Now, I can think of that 2 out in front as 2 over 1. So I have a fraction times a fraction. That 2 needs to be distributed across the numerator. The 1 needs to be distributed across the denominator, but that'll just keep it the same. And there we go. We have a formula for the composition g composed with f, and one for the composition f composed with g.